Okay guys, today we're going to talk about prime factorization, so let's go over it. We got a couple slides here. I'm going to go relatively quickly through this. You should know some of this stuff, or hopefully know some of this stuff. Make sure you write down these definitions. If you got to pause, remember, go ahead and pause. I'm going to go through these pretty quick. So this lesson is on prime factorization, so make sure that's your heading of your paper. And we're going to do some other things around that, but ultimately we're going to get to prime factorization, what you do with that. First, we need to talk about some background information, and the first is a factor. And factors, guys, are whole numbers that divide into a given number without a remainder. So if I give you a number and ask for the factors, you want to find the numbers that multiply to equal that number. So that's what a factor is. Factors make up numbers. It's what the product multiplying to make up a number. We have prime numbers and composite numbers. A prime number, guys, has exactly two factors. A prime number has exactly two factors. And then we have a composite number which has three or more factors. Okay, and these are we're all working with all whole numbers in today's assignment, so we don't have to worry about any negatives for at least the time being. But prime numbers we're working with are whole numbers, and composite numbers we're working with whole numbers. Remember, whole numbers are just positive. They are not our negative numbers. Okay, and then the last one is 1, because the number 1, when you're talking about prime and composite, the number 1 has only one factor, and that's itself, because it's 1 times 1. And that is neither prime nor composite. You may want to make a note of that 1 is neither prime nor composite, or at least make a mental note of that. If you need to pause, go ahead. Otherwise, I'm going to move on. First thing I want to talk about is listing factors as a prime or composite, so let's go over these. So when I want to list the factors, I want to list the numbers that multiply to equal 24. So I'm going to start with, I'm just going to make a little chart here to answer this. So I'm going to do 1 times 24, and then I'm going to do 2 times 12, and then 3 times 8. I'm just going to go in my mind through the numbers. 4 times 6, 5 times nothing, and I've already got 6 on my list, so I'm done. So now I'm just going to list it off, because my answer asked me to list them. That's just kind of work. So my answer would be 1, 2, 3, 4, 6, 8, 12, and 24. So that would be my answer of listing out the factors. Is it prime or composite? Well, it has definitely more than 3 factors, so this would be a composite number. It's composed of other numbers. So that would be my answer for number 1. For number 2 there, 17, I'm going to list out my factors. So I got 1 times 17, 2 doesn't work, 3 doesn't go into it, 4 doesn't go into it, 5, 6, 7, 8, 9, 10, no. Okay, nothing else is going to go into it, so my answer is 1 and 17. I have exactly 2 factors, so this would be a prime number. Okay, so that's how we do our factors. And the technique I showed is just one way of doing it. There's lots of ways of doing it. Some of them you can just do in your head. They're pretty easy. But making the table is kind of an organized way of doing it. And then you tell if it's prime or composite. If it has exactly 2, it's prime. If it has more than 3, it's composite. And remember, 1 is neither prime nor composite. Okay, if you need to pause that, go ahead. I'm going to move on. Okay, now we're going to get to our prime factorization. To do prime factorization, we're going to do what we call factor trees. Now, if you haven't done these before, these I find relatively fun. What I'm going to do is I'm going to break 36 down into its prime factors. So I'm going to find the unique set of prime numbers that multiply to equal 36. Each number has its own unique prime factorization. Okay, because I can repeat my factors here and I'm listing them. I'm looking for all the prime numbers that equal 36. So we're going to go through and use these. So you kind of got to think about the numbers that are prime. So for 36 here, guys, first thing I'm going to do is I'm going to break 36 down into something times something that equals 36. I could do 2 times 18. I could do 4 times 9. I could do 3 times 12. I could do 6 times 6. I got lots of options. I'm going to choose 6 times 6. It does not matter which option you choose. I do mine slightly different than some books, so you can do it my way. Now I look. 6 and 6, they are both composite. Okay, I'm looking for prime numbers, so I'm not done yet because they are not prime. I got to get to prime numbers. So what I do then is I break them down with some more branches. I figure out that what times what equals this 6. That's 2 times 3. Do the same thing for the other one, 2 times 3. Now I look to see if any of them are prime. All of them are prime. This is what I do with prime numbers. I circle my prime numbers. That means I'm done with them. I found them. Okay, now I have no more composites left. If I had another composite, I'd have to keep making branches going on until I was done. So that's all my work. That's my factor tree. So now I want to write the prime factorization. Well, what I have here is 2 times 2 times 3 times 3. And I'm going to write this using exponents. So my final answer is going to be 2 squared times 3 squared. That is my final answer. 2 squared times 3 squared. Okay, and if you do the math, just to check your work, 4 times 9 is 36. It works. That's the unique set. Okay, and it doesn't matter what path you took. If I would have done 18 times 2, you don't have to write this one down if you don't want to. And then 2 circle 2, and then I did 9 times 2, and then 3 times 3. Look at what I have here. 2 times 2 times 3 times 3, or 2 squared times 3 squared. Doesn't matter which set you take, you will get there. Okay. Let me do another example, so if you need to go ahead and pause, go ahead. For 180, I got a lot of options with 180. I'm going to start with a nice 18 times 10. Okay, gets my numbers much smaller quickly. I don't have anything that's prime, so I got to keep working off them. So for 19, I'm going to do 6 times 3 just to change it up from before. Okay, and then for 6, I have 2 times 3, and they are both prime, so I'm circling them. I still have my 10 over here to work with. So now I'm going to go back and work with that. That is 5 times 2. I'm going to circle those. Now I have everything circled. I have no more branches to make. So I write my answer. I have a 2 times a 3. A 2 times a 2 times a 3 times a 3 times a 5. So my final answer is 2 squared times 3 squared times 5. Yes, you can just write your answer in exponent form first and not write this step right here. That's okay. But it's good to write it out. Make sure that you have every number circled. The one thing that we don't use, guys, is 1. So you never want to make a step 2 times 1. You never want to do that. Okay? 1 is neither prime nor composite, so we don't want to get into that. If it's a prime number, then we're done. If it's not prime, don't use that number times 1. That does not help the cause. Okay? Let's go on to our next slide. If you need to pause that, go ahead. That's prime factorization using factor trees, by the way. Prime factorization using factor trees. Okay. Next, I want to talk about factoring a monomial. A monomial is a number, a variable, or the product of one or more variables raised to a whole number power. So it's a combination of those. So let me give you some examples of monomials. Okay. Here's some examples of some monomials. Could have 6a, we could have 12x squared y, we could have 15ab. Okay, those are some examples of monomials. It's a single term is what it is. It's a single term. Okay, a non-monomial, okay, these are not monomials. You'll notice something about these. They all are going to have a plus or minus sign in them. Okay? Those are multiple terms. Mono meaning one. Monomial. So monomials all are one term. It's a combination of numbers, letters, and it could just be a number. It could just be a variable. Those are also monomials. So if I go back to that, 6 is a monomial, x is monomial, or a combination thereof. Not a monomial, guys, has a plus or minus sign in there. Okay, so that is not a monomial. Okay, now I'm going to go on to my next slide since class is going to begin pretty soon here. So let's get to my next slide. In the final slide here, guys, I want to factor these monomials. Kind of like my prime factorization. So first thing I want to do is break 6 down. That's 2 times 3. A and B I don't have to break down. So my final answer for this one would be 2 times 3 times A times B. That is my final answer. Okay, and actually, I'm going to actually write dots in between those, just because I'm using variables. Okay, and you don't want to mix up the x as a symbol x versus a multiplication symbol. 2 times 3 times A times B. That is how I want to break that down. Okay, when I'm factoring something, I'm breaking it down. Now, this is not prime factorization where I'm using exponents. I'm actually just breaking it down into its smallest form there without exponents even. For 15, that's 3 times 5. So that is going to be 3 times 5. And then I break down my x's. I have 3 of them. And again, I want to write them without exponents because I'm breaking them down into their lowest level, so it's just going to be times 3, or times x times x times x. 3 of them, since it's y squared, that's going to be times y times y. So my final answer would be 3 times 5 times x times x times x times y times y. And so I'm breaking it down into its smallest form. And that is a monomial. Okay, that's it for our lesson today. We'll go over this in class. Have a wonderful night.